Alright, so we're going to walk through silicon and do electron configuration, orbital diagram, all that kind of stuff for silicon. Alright, so I will do that right over here. Alright, so silicon. So if we look at silicon right here, it has 14 electrons. So we're going to write out first its electron configuration. So remember, we're always going to start off in the 1s right here. So 1s, remember s can hold a maximum of 2. So then we keep going. The next one is this 2s. Remember, 2s also can hold a maximum of 2. Any s's can only hold a maximum of 2. So now I keep going. So there's my 2s. You're just reading left to right. The next part is 2p. Remember, p's can hold a maximum of 6. So right now, I see that I've put away 2, 2, and 6. So that's adding up to now 10 electrons. Remember, I have 14 electrons. So I keep going. The next one is 3s, 2, and now we keep going. Our next part is 3p, and remember we're just going to si, so that's 2 in to get to si. So now we can also double check. 2 plus 2 plus 6 plus 2 plus 2 gives us the 14 electrons that we had. So we just gave the arrangement of all 14 of those electrons for silicon. For the orbital diagram, that's when we represent the electrons in the boxes in the orbitals that they are in. So we saw this in the gizmo. So remember, the 1s can hold 2. Our next part, I'm just going in my order now, is 2s, and I have 2 electrons in there. Remember, the arrows go in opposite directions. And now the next part is my 2p. 2p is all full. Next one is 3s, 3s, and now 3p. So looking at 3p, there's only 2 electrons there. So remember, each one is going to get its own. Each box within the 3p is going to get its own before you double up. So that's how it would be. It would not look like this, right? It goes back to the gizmo when, like, you're getting on a bus, you're going to go to an empty, like, row before you start sharing a seat with somebody. So they're not going to share, they're going to each want their own, and then if there is more, then you would go and like double up. But there's just 2 in the 3p. So that's an orbital diagram. In terms of valence electrons, remember, valence electrons are your outermost electrons, the ones on the farthest out shell. So if I look at this, what's the energy level? What's the shell that is the outermost? It's the third, right? The 3 was your farthest. You don't have any in the 4 or 5. So looking right there, how many electrons do I have in that third shell? Well, 2 plus 2. So I have 4 valence electrons for silicon. So one other thing I wanted to practice is what's called the dot diagram. Dot diagram. So dot diagram just shows those valence electrons. So like we just figured out, silicon has 4. So what you would do is you write this symbol, and then you're going to represent each of those 4 electrons with just a single dot around the sides of this element. showing that those are the electrons that can bond with another element and form a compound. So we have 4, so each side will get 1, like so, similar to the thing with the part about getting on the bus and stuff, getting your own before you start doubling up. So if I had more than 4, like I would just keep going around. So I went 1, 2, 3, 4. Then the next I would just keep going. If I had a 5th, or if I had a 6th, if I had a 7th, or if I had an 8th, they would go around like so. And obviously, remember, you won't have more than 8 in an element. Remember, to be stable, it wants to be like those noble gases. So remember, since they want to become a noble gas, some elements will either gain or lose electrons to become like a noble gas. So, for example, silicon, once it forms an ion with that 4+, that means, since it has 4+, that means it got rid of 4 electrons, because now it has a positive 4 charge, and that you don't have the same amount of protons and the same amount of electrons to cancel each other out and be neutral. So since it got rid of 4 electrons, how you would write its electron configuration for this ion is, so remember, this was the regular electron configuration. Well, it's getting rid of 4, so basically it's getting rid of those 4 valence right there. So the electron configuration would just be 1s2, 2s2, 2p6 for this ion. You probably also saw in the gizmo that once you get down to electron configurations of, for example, like gold or europium, they have a lot of electrons. So your electron configuration gets to be really, really long. There's what's called the abbreviated or noble gas notation. So how that works is you pick the noble gas that is before the element. So let's still work on our silicon. So remember, these are your noble gases. Noble gases are in group 18. Noble gases, sorry, this is so messy. So the noble gas that is before silicon is neon. So what you would do is you write neon in brackets. And then you're basically saying, okay, skip to neon, and then you're just tacking on the extra electron configuration to get to silicon. So in that case, we're just picking up where neon is. So what we hit is 3s2. So 3s2. And then keep going. What do we hit next is 3p. And then it's 2n from the 3p. So if we were to do another example, so let's try europium, EU. So the noble gas that is before that. So remember, all of these, like this lanthanide series, remember it's going in like right here because it jumps from 56. Number 57 is down here. And then at the end of this, once you get to 70, 71 is right up there. So it's like this row is up there, and this actinide series kind of fits in right there. So if we were to do europium, the noble gas that's before it is Xe, so you'd write that in brackets. And then we're just picking up right there, so it'd be 6s, 2, and then remember we're going to pop down here to get to europium. So that'd be 4f, and then how many in? 1, 2, 3, 4, 5, 6, 7 in on that. Okay, if we were to do, let's do HS. HS, the abbreviated noble gas notation. The noble gas that's before that is right there, Rn. So put that in brackets. And then remember, we're picking up right here then. So that's 7S, 2. So now at this point, remember, don't go straight into 6D. You're going to hop down to 4F right here. Sorry, 5F, 5F. 5F. You can go through all of them. So remember, F's can hold a maximum of 14. There's 14 there. Then once we get to here, right, we're popping right up here. So that's your 6D. And then just count in 1, 2, 3, 4, 5, 6. Yes, just like that. So that kind of basically puts together a lot of the different things that the Gizmo is talking about and that we talked about last week, but I know it's been a while with fall break and everything like that. Hopefully that was really helpful. Remember, you have your test on Thursday. So come see me as soon as possible if you need help with these things. And good luck!